We're on question number 4. Calculate coordinates of the point of inflection of f. To calculate the coordinates of point of inflection of f, we need to find the first derivative, second derivative, then equate to 0 and so for x. The first derivative, f prime of x, is equal to 3x squared minus 8x minus 11. Then second step, then the second derivative, this gives us 6x minus 8. Then we equate this one to 0. So then 6x is equal to 8. Then we divide by 6 both sides. This will give us x is equal to 4/3. That's our point of inflection. But this is the x coordinates. We need to take back this x into the original equation. This gives us 286/27. Our x coordinates is 4/3, 286/27. Next question, sketch the graph of f. Or to sketch the graph of f, we need to show x-intercepts. The coordinates of x-intercepts that we calculated, we had y-intercept 0 and 30. Then the turning points -1 and 36. The other one was 11/3 minus 400/27, but let's take it in decimal form. 3,67 and minus 14,81. So on our graph, we need to mark x-intercepts. So our x-intercept is xc is equal to -3, then xc is equal to 2, and x is equal to 5. Then our turning point is -1 and 36. So this is -1, maybe 36 is somewhere up there. Then another one is 3,67 and -14. Then -14, I can mark it here. Then I can sketch my graph. So this is our graph with the x-intercepts marked here, 3, 2, 5. Then our turning point is -1 and 36. And another one which is 3,67 minus 14,81. Then you need to mark your y-intercept, which is equal to 30. The point of inflection is the central point, 4/3. 4/3, which is estimated to 1,333 recurring. So 1,33, you may find that is somewhere there. So this is our point of inflection. Next question, for which values of x is the graph of f concave up or concave down? From this point of inflection, we can see that starting at this point going this side, the graph is a U shape, so that's where it is concave up. Then from this side going this side, it is concave down. Point of inflection will determine the side of the graph where it is concave up or concave down. The question was asking for which values of x the graph is concave up and concave down. So for concave up, point of inflection, the x coordinate was xc is equal to 4/3. So this means from 4/3 going to the right, our graph is concave up. So the values of x is x greater than 4/3. Then concave down is the opposite, it's less than 4/3. Or x is greater than 4/3 can be represented in form of coordinates, where we use the square brackets and the round brackets. X is greater than 4/3. So meaning our solution is from 4/3, x is an element of 4/3 up to positive infinity. Then the other one, x is less than 4/3, meaning 4/3 is the last number. The rest should be below 4/3. So meaning x is an element from negative infinity to 4/3. And number 7, for which values of x is the graph of f increasing and decreasing? When we say the graph of increasing, we check where the y values of the graph is increasing. For the points where the graph is increasing, we check it from the turning point. So our turning points is this one and that one. So as you can see from this side, the graph, the y values are increasing from 0 going up. But as you can see from this point, the y values now starts decreasing until we reach the other turning point. Also, as we are from this turning point now going that side, going this side, you can see now the y value starts to increase going up also. So the points where the graph is increasing when x is less than -1 and when x is greater than 3,67. When the graph is decreasing, from this point up to this point. So it's from -1 up to 11/3. So this is less than x, which is less than 11/3. Or you can represent it in coordinate form. x is an element of -1 up to 11 over